Okay, so day plan. We do one. We finish off this. We go for design. Our focus is to the design. So this week and next week. Okay, so you write the report. Try one. Track the experiment. I have to do D1. Okay. This time let's see. Okay, so as I said, this is the one example of the setup to find what? To prove the acceleration, right? What's the question? To prove this acceleration formula. To acceleration formula, they already give a pulley system. If they give a system, you can use it in exam. Okay, with additional instruments. Okay, so in this case, okay, if you want, you can use a retort. What do you call? You can use your light gate. You can use 2 light gates. You can put a 1 light gate nearby to the mass, another 1 light gate maybe somewhere here, and the distance between the 2 light gates is the h. Okay. You can use light gate connected to an electronic timer. You can draw a box and show it's an electronic timer. Okay. So you can say time interval of movement can be found from the electronic timer. Okay. More accurate instrument. What is the function of 2 light gate? To find the time interval. Okay. Find the initial and final speed, but I found all the mark scheme, most of the mark scheme, they go for light gate for time interval. Okay, time interval. So when the object passes the first sensor, you start the time. When you go to the second sensor, you stop the time. You give the time interval. What is the good of light gate compared to the stopwatch? What is the benefit? Very no reaction time. Sensor. Okay. Okay, but if you use stopwatch, still allowed. Many techniques allowed. Okay, the first is experiment. So these are the 3 variables fully in your list. Okay. Okay, so independent variable, the mass of B, the dependent variable, the acceleration, and the variable to keep constant, mass of A. What you're going to plot? The y-axis is your dependent, right? The x-axis is going to be your independent always. Okay. The graph you're going to plot. X-axis is going to be dependent. The y-axis should be your dependent. So variable constant is MA. So you get 2 marks if you write this. Okay. Okay. Procedure focus to what? Procedure to focus to how do you measure the independent, dependent? How do you make the variable to be constant? What instrument do you use? What formula do you use? That's what you get marked. Okay, this is one example of procedure. This is not in a point form. You write in a point form 1, 2, 3. Put numbers better. So mass of the body P using a top end balance. Yes, top end balance 1 mark. Okay. Measure mass, top end balance 1 mark. Measure distance h shown in the diagram, no mark yet. But ruler not stated by using a ruler. Okay. So measure the time for the object travel h using a stopwatch. Yes, 1 mark. Stopwatch, timer, light gates, stopwatch or light gate. Okay, interval, time interval. 1 mark for this, the instrument. Results then calculated, acceleration h equals to half at squared. Since u is 0, repeat the experiment with a different value. So the equation to calculate your a, so 1 mark. Measure the distance h. Should say what instrument. If you never said here, they go and look at the diagram. Or diagram, do you put any ruler or no ruler? You don't want to get mark. Must say instrument. So please include the instrument. Measure the distance h by using a ruler. Then only you get mark. Must mention instrument. Okay. Okay, so done procedure. Procedure how many marks? 4 marks. 1 marks go for the setup, the picture on top. Another 3 marks. Okay. Another 3 marks all tell instrument, any formulas, any special technique. Okay. Okay, write it in a point form. Don't put it in a paragraph. Difficult for the examiner to identify the information. Make it a little easier for the examiner. If I hear H, I didn't put ruler, but in the diagram got ruler, you get mark. Okay. So picture is 1,000 words. So try to include every instrument in the diagram. You forgot to write in the statement. If it's in the picture, then you get mark. Okay, so procedure, how to measure independent, dependent, and how to make the constant, the variable to be kept constant. What instrument, what technique. Okay, the title can go procedure or method. Method, procedure. Give a title to. Okay, so next is what? Analysis. Analysis, 3 marks. What you should say? What versus what to be plotted? What is the y-intercept? What is the gradient? And how the graph going to look like? Straight line. That 4 things you should tell. What versus what to be plotted? It's going to be a straight line. By obtaining a straight line, the same wording as your qualitative, what do you call it? The analysis part. Plot what something was. In this case, what versus what? H versus t squared to be plotted, right? By obtaining a straight line where gradient is of a and y-intercept 0 would enable us to validate the relation. Okay. Oh, 1 over mb, right? Graph acceleration. A versus, A 1 over mb. A versus 1 over mb. Yeah. So A gains 1 over mb to be plotted. 1 mark. A straight line, 1 mark with a negative intercept obtained, where the negative intercept is negative g. And the gradient is what? An equation can even include a gradient also. What's your gradient? Go back to the equation just for a while. So yeah, the gradient is WA. The gradient is WA and the y-intercept is negative G. So please state the gradient is WA. Include that too. The graph straight line with the negative intercept, which is negative G, and gradient as WA. Then equation given is, well, mention gradient and intercept. Okay. And then say summary mark, 3 marks. Can go for the fourth mark, they can give as a detail mark. Okay, detail mark. So we did a lot of linear law. I think this mark you should get all the 3, sometimes 4. Okay. Okay. Next analysis. Precaution. We never put a separate title. After that, it's all extra detail. We put the title as extra detail. Under extra detail, you can put one precaution. Okay. A new format. Just put extra detail. The precaution, just put it under extra detail. So precaution. The document I give you that day, there is a list of precautions for you to do. If there is heavy masses, just send back a bucket of sand at the bottom so that fall into the bucket of sand. And G clamp can be used to prevent from toppling. So safety goes for 1 mark. They give 1 mark for safety. You write 2 safety, I don't think so you get 2 marks. 1 mark for safety. The others something else. Okay. Okay, so the difficult part is the last one, extra detail, more clarity. How much you can clarify the more details about the setup. So some suggestion here. Yeah, whenever you involve pulley, you say frictionless pulley. Frictionless is one extra detail. Use clamp to support the holder of the pulley. Increase the distance H in order to reduce the percentage uncertainty in the measuring of T. It's a very good point, the third one. Whatever measure you have a choice to measure, try to have a bigger measurement possible. Okay. More greater the measurement, we learn that the percentage uncertainty for that measurement is smaller. So if you have a choice, of, let's say, selecting a diameter for wire, go for a big diameter, reduce percentage. Okay, next, mass of body B should not be too much. If it's too much, the acceleration, the acceleration going to be small, right? Too much, smaller than mass of body A. Smaller than mass of body A, as acceleration might be too high, too high fast. So do a preliminary experiment to find out which mass is suitable. You don't want the acceleration to be very huge. Very huge, your reaction time is going to affect the time interval. Any other detail you feel can be added? you can talk about ruler. And when you measure the edge, make sure the ruler is perpendicular from the ground by using a set square. Extra details that can be added. Okay, these 2 points, the last 2 points, you can add any experiment, viewing the reading at eye level to minimize the parallax error, and repeat the measurement and obtain the average. That's another one factor which can use, but not always confirm that they're going to give mark. Okay, these are very common ones. Okay, but better you include under digits. Okay. So read for the ruler, read the reading at the eye level to minimize the parallax error. Repeat the measurements and obtain the average. That's when you write this, don't include it in your mind that as an extra detail. This is like out of the 6. If you're lucky, they can give you 1 mark sometimes. Okay, so add the ruler, make sure the ruler is perfectly vertical. Measuring the edge by using a set square. Repeat the measurements and obtain the average. Read the scale at eye level to minimize the parallax error. Classes writing going to be easy once you got the picture, the setup. While you are drawing the setup, I think after that, if the drawing is correct, the setup you feel you can visualize it, then the writing will be easier. But if your setup is wrong, not workable, you lose most of the mark. I think around 5 to 6 marks you will lose. Maximum you go, I think around 8 marks maybe. If the setup is wrong, okay, not workable. Cannot find the acceleration. The method they use, maybe if it try to slide horizontally or something, not workable, then you won't get much marks. Okay. Okay, so this is matter of practice. Just started with one, so you go for another one. Figure out the setup. Use the guidance, the file I give you. What to measure, what physical quantity, what instrument to be used, the list. Okay, we go to the next one. For just about 5 minutes, try to figure out the setup first. Okay. Let me check which one best. I go different type. I don't think so. I'll go for 2 first. Okay. D3. Read the question, try to figure out the setup. Here a list of apparatus is provided. You can use this list, or you want to add something else not from this list also allowed. Okay, this is just a suggestion. You can use it. You want to do on top of that, you want to add some other instrument from what is in this list, still allowed. Design an experiment to find efficiency of a motor. Say a motor given to you, how do you find the efficiency of the motor? What measurement to take? Efficiency is what? Output power over input power. How do you measure the output power? How do you measure the input power? Output power only can be measured if you make the motor to do work. Easy way is pulling up something up. Like a mass, dotted mass, like pulling it up. So the motor will do work. So we measure the power, output power. Input power we can measure by supplying the what is the input power? The electrical power, right? connect the motor with circuit board, right? The input power can be measured by using what formula? The electric power, I and V1. P equals to IV. You can measure the input power. So the motor connected with the ammeter and voltmeter, some sort of the circuit you must show. So that how do you connect the ammeter and voltmeter to get the input power? And how do you find the output power? Output power, that the load goes up. So it does work. How do you measure the work? What type of energy change to what type of energy? I think the work done by the motor tend to become gain in potential energy, right? So MGH, you can find the work. The gain in potential energy by the load is the work done by the motor. How do you find the output power? The work divided by the time work. So you need to measure the time for the load to go up to find the output power. Okay. Output over input can give you the efficiency of the motor. So draw a rough sketch. What instrument need to be connected? What measurement to be taken? And what versus what graph to be plotted? 5 minutes for you. Important is sketch one diagram. I know this is the difficult part, but try to draw one. It won't be accurate at the beginning. Maybe if you don't know the shape of the motor, you can put a box or whatever. You can label it as a motor. It's fine. You are checking the physics idea, not the art. So imagine when you write this, the drawing this, imagine like maybe your sister or brother want to use this procedure to do the experiment, who don't know physics much. So give lots of clarity in your explanation. Subject draw, let me have a look, maybe 5 minutes for you. Okay, so head ruler, how to measure the height, double the height. Bucket of sand at the bottom. Put a ruler at the side, maybe with the third stand. Must have a rheostat. Must have a rheostat. Variable risk. Rheostat. Variable risk. Oh, had a variable risk. In your diagram, you should have ammeter, voltmeter, variable resistor. I think you need to have variable resistor, switch, ruler, motor, of course, motor need to be clamped by using a G clamp, because when it pull, motor might follow the direction of the pulley. So we need to clamp it. Motor. That idea must come in mind. Motor need to be clamped. Motor is on the wooden block. So label diagram. Label it. spend some time to your picture. Once you get the picture correctly, the writing normally it will be easier. Okay, for the mass to go up also you can use light gate if you want the height time taken to rise up. So you have a slotted mass here, maybe you can use a light gate here. You can use a light gate here. Light gate is something like this one. Okay. You can put another light gate here. Sorry. This should be longer. You can put another light gate here. Connected to a retort stand maybe. And this mass have to be at the bottom here. Mass should pass through the what? Mass must pass through the gap. Okay. Gap to go up. Maybe you have a pulley here. Maybe. This two light gate is connected to a maybe electronic timer. Or you can use stopwatch. If you use stopwatch, then have a ruler at the side. Ruler clamp with the G clamp. The retort stand. In the description, you see set square used to make it perfectly vertical. Okay, your ammeter voltmeter connection, they will check. Ammeter must be in series with the circuit, voltmeter must be across the motor, right? Parallel. Okay, so let me show you one setup. One setup. So maybe you draw 2D is fine. It's not wrong. It's good to have 3D if you have time. If you don't have time, 2D. But as long as the connection all are correct, okay. So the voltmeter have to be parallel to the motor, okay. And ammeter is in series with the source. Okay, you must have a variable resistor to make sure the current flow is constant. Because you prolong connecting the motor, the heat generated, so the current will drop. the current drop, the input power going to drop. We want to make the input power constant. I times V is your input power. So we must make sure the I is always the same. So what you do, we adjust the rheostat so that the current is always the same. Okay, that's why you need a variable resistor. Okay, so you clamp it the wooden block, then you go to the wire at this side. Of course, I believe many of you have the pulley, the rheostat, and the slotted mesh. Okay, ruler perfectly vertical, or you can use the light gate if you want to light gate. Okay, so input power we calculate by using I times V. Output power we calculate by using mgh over time. The work done to rise the height, the potential energy over the time is your output power. The pulley in the diagram, you can put frictionless pulley, or you can write later under detail. Okay, so now write the variable to be manipulated: independent, dependent, and constant. Write the method. Okay, independent, dependent, and constant. Okay, so this should be a independent, dependent, and constant. Independent is your what graph you're going to plot. Your x-axis, I think load, weight of the load. Dependent is your y-axis. In this case, the efficiency of the motor. Because the equation given is efficiency with load, right? And constant variable is the input power. Input power, we make it constant. Okay, now write the method. You can start with set up the apparatus as shown above. Then you give detail about the measurement. What instrument? What instrument measure what? How do you calculate the input power? Explain the method. How do you calculate the output power? Use the show the formulas to be used. So, for example, measure the current from the ammeter and the voltage from the voltmeter, and the input power will be I times V, P equals to IB. Write yours first roughly, then I show like sample. Hope matches with the sample. Okay, write roughly your idea first. What are you going to write for? Focus to the instrument equation. Okay, you can start right. Method is what? Set up the apparatus as above. Set up the apparatus as shown above. Okay. So let me show you a sample method. Hope this is what in your mind. Voltmeter connected parallel with the motor while ammeter in series. You need to state that. If you state okay, good, but you never state also in the diagram is connected correctly, you get mark. That could be extra detail mark for that connection. Output is MGH over time. In exam, don't write just MGH over time, and you don't expect the examiner to know what is M, what is G, what is H. They will know M is mass, but you must state MGH over time, where M is mass, G is gravity, H. You have to state that. The symbol represents what. So 1 mark for MGH over time. 1 mark for the input power IV measuring ammeter and voltmeter. And third is the efficiency output over input. 1 mark for the method, for the diagram. Okay, so after the procedure, write the analysis. What graph, what versus what is the what shape going to be, what is the gradient, what is the y-intercept. I think this graph you need to bring log or ln, right? The equation, the power is what n. So you have to expand the equation, and I think log or ln, right? So expand it, either log or ln to be used, and final formation equation you must show in form of y equals to mx plus c. So the final equation, then you say plot log what versus log what. Internal gradient is what, intercept is what. Then the relation is, well, Okay, so yeah, analysis part. Log E versus log W. The equation is valid. The gradient graph gives the value and sign for constant n, and include the intercept too. Include intercept is missing here. Please add the intercept. What is the equation? What is the equation? E equals to. Hold on. EWH. E what? AWH. So log. So log E equals to what? H log W plus log A, right? Okay. So show this equation. Show this equation. Here they never show. Show that the equation can be written as this as the first point I can write. If you show this equation, could be a detail mark. It could be a detail mark if you show the final equation. So plot log E versus log W, where the gradient is your H. Your gradient is your H, and your y-intercept is your gradient is H or N? N, right? N. H. Sorry, yeah, H. So gradient will be H. The graph straight line, 1 mark, and the equation is valid. The gradient graph gives the value of H, and please include the intercept. And the y-intercept is equals to log A. So this 1 mark. This will be 1 mark. This will be 1 mark. This could be a detail mark. Okay, it could be a detail mark. The equation. These three like the analysis mark. This three is like the analysis mark. So analysis mark. Okay, so up to here is fine. Okay, the extra detail is the difficult part. You need to how much of clarification you give to the setup. Extra detail can go for maybe frictionless pulley, series parallel for ammeter, how they connected. Okay, adjust the variable resistor so that the current is always constant to make sure that power input is constant. And make sure the ruler is perfectly vertical by using a set square. So on. Use the greatest height possible to have a lowest percentage uncertainty. Read the reading at the eye level, repetition to minimize the parallax error. And so on, and the extra details. Okay. Okay, let me go back to the. Sorry, which one? Yeah, so this is the precaution. String is used, so back goggles. Clamp based lithostand G clamp to prevent toppling, catch a falling mass bucket of sand, prevent damage to the floor. And wear goggles to prevent, because if it snaps, if the string snaps, the string, what do you call it? The wire snaps, then it's going to be dangerous. So wear goggles. Okay. Only one safety. So all the pulley to reduce the friction, or use a frictionless pulley, holder of pulley, increase the distance h to reduce the percentage uncertainty in time. Plus, sorry, what I'm showing here. I'm showing the wrong one.
You're showing the wrong one. You're showing the previous one.
Yeah, nobody asked me. It's Moto, right? So this is your the first experiment.
Yeah.
Yeah, which color? Fine, please. Wear safety goggles. Wear safety goggles. Do not huge current may overheat. Use a preliminary experiment to make sure the values of time to go up is not too small or too big. The connection series parallel also could be one more detail. And the analysis, the formula final derivation also could be one detail.
Suitable.
Yeah.
First one, look up preliminary experiment.
For exchange of load.
Suitable value.
Yeah, suitable value. So preliminary experiment, do the preliminary experiment to each change of load. Suitable values for time, load, current, and voltage. We don't want the time to be too short, mainly the time. Too short, reaction time will be big, so the data are not reliable. So you must have a suitable I, V, and the load values. Don't have too much of power. Then you're going to rise up fast. don't have too much of load, you're going to be slow down. So you must do a preliminary setup first to check. The time is quite maybe 4 or 5 seconds, reasonable timing, not too short, not too long. Too long, okay, good, but time consuming. Nicholas, so take a 5 minutes break, then we continue. So take a break.
Just can I write a switch on the circuit so that when hitting switch on the circuit when hitting out
Waiting, yeah. Waiting. Don't prolong switching on.
And then try to do like that.
Okay, good. So you use like electronic timer. Only one. Only one time. One box, both light gate connected. The box is only one side, but there is two slots to connect. So put one side. Okay. So, okay. Good. That's okay. Add a switch here. Okay, that's fine. Okay, switch. The power supply. Yeah, here again. So another 15 minutes, then I stop. Just 15 minutes. What I want you to do is the design, just the diagram only, not the complete coding. Just the diagram. Okay. You spend about 10 minutes to draw the diagram. Okay, then we stop. Okay. Yours just 10 minutes. Default. Just draw the diagram, setup. How do you think the setup should look like? You can discuss with your friends if you want. How the amplitude of the transmitted sound depends upon the density of the material it passes through. So an architect is drawing a plan to block of flat. She's considering what material to be used for floor. If the material is very dense, then there is a little transmission of sound from one flat to another. But the building costs are greater because the structure has to support a greater weight. So cost cutting, so they don't want to use very dense. They want to use reasonable density so that the sound is reasonably not really transmitted. So scientists predicted, this is the formula, how the amplitude drops, how the amplitude of the sound drops after passing a thickness of X. This seems like your ultrasound thickness. It drops exponentially, the intensity. intensity of sound. X is the thickness of the material. So design an experiment to test if the theory applies on this situation. Is it correct or wrong? Design an experiment to prove this formula. How the sound amplitude drops after passes a certain thickness of a material. So what is the manipulated variable here? Thickness of the material. What is the responding dependent? The amplitude of the sound after passes the material. Okay, how do you going to have a setup? What instrument do you think you have to use? 5 minutes for you. Okay, good. Yeah, closed container. Closed container? We don't want the sound to be reflected there. Reflected, then go to the receiver, then from reading already. So you can have a closed container, but the container must have a sound absorbing material. After passes only the material, that sound only reaches the microphone. Connected to CRO, yes. Microphone connected to CRO. A time base is shut down, just one the amplitude. How do you produce the sound? One instrument. Signal generator connected to a microphone. Sorry, speaker. Signal generator connected to a speaker to produce sound at a specific frequency you like. Amplitude also fixed in the signal generator. We fix the amplitude and the frequency. Material and microphone with the CRO in a container. Basically, that's the instruments. Try to draw one.
Can you use it too?
Tube also good. Yeah, tube. The sound directed, not spread around, directed to one side. Tube. But the tube should be the surface must be insulated. Air, what do you call sound absorbing material. Side of the tube.
The thing with your croissant.
Yeah. Ultrasound detector. This sound is sound below 20,000 hertz.
What's the image for your speaker?
For image, speaker, yeah. Okay, you can put a speaker. This connected to a CRO, maybe signal generator. You can clamp it if you want. Up to you. Generator, microphone, speaker, block, and microphone, CRO. Then the container, you can explain. You can put a container if you want. Sound absorbing container. And the sound frequency must be not too large or too low. Frequency need to be fixed. Okay, so I hope you have one idea. Maybe one example again. Hope this was probably in your mind. This one setup. Should have microphone, CRO, material, speaker, signal generator is the main instrument. This extra is the two thermostat is clamping the. Yes, the speaker and the height of the microphone must be the same height. Okay. You can't put the speaker higher and the microphone lower. It should be the same height, right? And another figure 2 was shown to tell that how to measure the density need to be measured. So what measurement need to be measured? Figure 2. If you want, you can have more than one figure. If you want. Okay, signal generator can fix the amplitude and the frequency of the sound. Okay, variable to cap constant, I think the frequency and the amplitude of the signal generator, the sound produced by the signal generator. Don't use very high frequency, painful. So that can be detail mark, okay, or safety. Okay, CRO, you can switch out the time base so that only the vertical trace is plotted. You can calculate the amplitude. Okay. Measurement of density, you know what? You learned that before. Use ruler to measure the size, or vernier caliper for the thickness. Measure the mass by using a top and balance weighing scale. Instrument all you mentioned. Okay. Then, of course, the experiment must be conducted in a room where there's a sound absorbing material at the side, so that no reflection happens and affect the intensity detected by the microphone. That could be a detail mark. Okay. And repeat the experiment with the different material with the different thickness. Okay, so this is the independent, dependent variable to get constant. I'll stop here and just take down the independent, dependent, and variable to get constant. Because densities change the density of material. Dependable is the amplitude of transmitted sound wave. Frequency of sound is constant. Oh, we're changing the. Dependent is density. Okay, the experiment is about proving what? Density with? Or density of the material with the intensity derivative, amplitude derivative. So the independent is, of course, density of the material. Dependent, the amplitude of the transmitted sound wave. A. The amplitude of the transmitted sound wave. Dependable. Constant is the frequency of sound. Okay, class, so let's stop here. Okay, this is your homework. Give a try. So next class we'll be discussing this. I also do C5, C6. Yeah, do C6, C7. Okay, it's a mark pass here. So I put the mark scheme on the time. You try to go through. Shouldn't be a problem. Same technique. If you don't understand, then you bring up in the class, and I explain. Okay, C6, C7, right?
Move down.
Yeah.
Move down a bit. I can see the content right now.
It's copy.
Sound absorbing material.
Yeah, if you put a full screen.
Why not the MTG? The MTG would sound absorbing.
Because we put it straight to the content part. What do you call it? The container from the material. We direct the speaker to that material. Sometimes the sound will move to the side, but this sound need to be absorbed. You see temperature drops, it's directing to one side. So we don't bother this temperature drops. But important, this sound should not be reflected. That's the main focus.
So did you record for today?
Yeah.
Did you record for today?
Yeah. Yeah.